Alright, this is part 6. We're going to be talking about division. So just like multiplication, I'm going to show you it on paper, then I'm going to show you the schematic for it, and then we're going to build a machine. So first let's do it on paper here. So we have a setup with long division. We have a 5 going into a 25, so this is 25 divided by 5. The first thing we look at when we do this is, can 5 go into this first digit here, which is just a 1, and the answer is no, so we put a 0. Then we move this line over and we look at the first two digits. Can 5 go into 3? The answer is still no, so we put another 0. Then we move it over again. We say, can 5 go into 6? The answer is yes, so we put a 1. And then we have to subtract the 5 from the 6. So 6 minus 5 gives us a 1. Now we have to bring this number down to line it up with the rest of them and put it here. And now we can look at the number again. Does 5 go into 2? The answer is no. So we put a 0. Now we bring another number down. And does 5 go into 5? The answer is yes. It goes in once. We subtract it again. And we get a remainder of 0. So now we have to look at how to put this algorithm into an actual schematic. For some reason, this is like way simpler to show in a schematic than multiplication, so I usually like explaining this part to people, because if you think about it, as we're doing division, we're really just shifting this 25 over, and we're looking at one digit at a time. First, we're just looking at the first one, right, and comparing 5 to it. Then we're looking at the next one, the 1, 1, and comparing 5 to it. Then looking at the 1, 1, 0. So this 25 is just getting shifted in one at a time from the left. And every time it gets shifted in, we're doing the exact same thing. We're just asking, can I subtract 5 from it? If not, put a 0 and don't do anything. If I can, put a 1, do the subtraction, and then just continue as normal. So gradually those zeros and 1s that we get from either subtracting or not subtracting give us our answer. And so this is the schematic for it right here. It's doing the red divided by the blue. And so the red is going to get shifted in from the left so that we look at the 1 and then the 1, 1, etc. This orange is a conditional subtractor. It will only subtract if it gets a positive answer, or an answer that's like 0 or above. And if it can do the subtraction, well, it'll output a 1. And this sign bit, if you remember from subtraction, if we got a positive answer, the sign bit is already a 1 if it's positive, so that works perfectly. So let's just try this out. So let's do 25 divided by 5. So we're first looking at 1 minus 5, and it can't do it. So the first bit of our answer is a 0, and I'm going to use green wool to mark that this bit is finished. Now we're going to shift it over, and now this is looking at 3 minus 5. 3 minus 5 you still can't do, so we have another 0 in our output. So far our answer is 0, 0, and it's looking good so far, because when we did it over here, the first part of our answer was also 0, 0. So let's shift this over again. Now we're doing 6 minus 5. Now I can actually subtract. 6 minus 5 is a 1. And the sign bit is also going to be a 1 because it's a positive answer. I'm just going to put it over here because that's how our answer has been displayed so far. And it's also going to replace the red with whatever the answer was. So it's going to put this 1 down here. Because remember, after doing the subtraction, it uses this new 1 as its new reference to compare the 5 with. So now we're going to shift it over again. Now it's doing 2 minus 5. I can't do that, so put another 0. Shift one more time, and we get 5 minus 5, which is a 0, which we're going to call positive because it could do the subtraction, and that means our last output is a 1. And then of course it puts the result of the subtraction back into the red, and our remainder in the red is a 0. And our output over here, 0, 0, 1, 0, 1, this is a 5. Alright, let's do another example, and this time with a remainder so I can show you how that works. So the red this time is going to be 27, the blue this time is a 6. So we're doing 27 divided by 6. This should give us an answer of 4, remainder 3. So we start with the 1 minus 6. I can't do that, so the first answer is a 0. Shift everything over. Now we're doing 3 minus 6. I still can't do that. Second bit of the answer is also a 0. Shift everything over. And now we're doing 6 minus 6, which I can do. So we put a 1 here. And the result of the subtraction is a 0, which gets replaced with this in the red. Now we shift over again. 1 minus 6 I can't do again. We put a 0. Shift. 3 minus 6 I can't do, so put a 0. So our final answer is 4, 1, 0, 0, and the remainder, which is going to be in this red part, is a 3. So you might be a little confused because I'm showing you how to do division with remainders, and yet this calculator that we're building gives an answer with a decimal point and 2 points of precision. So how does it do that? Well, it's not actually doing decimal points or fractions or any of that. I'm kind of cheating. And the way I'm doing that is I'm multiplying the top number behind the scenes by 100, and then I'm just displaying whatever the answer is. And then that decimal point right there is fake. It just comes up no matter what the answer is, because it'll always work out to give the right answer. So for example, what this is doing right now is instead of 2 divided by 3, it's doing 200 divided by 3, which is like 66, remainder something. And so 66 is being sent to the display, and it pops up there, and then the decimal point is just turned on whenever division is turned on. So before, with addition, subtraction, multiplication, the highest numbers they had to deal with was 255, because that's the max for 8 bits. Since division is using this trick, where we multiply the top number by 100, we're going to have to deal with numbers as big as 255 times 100, 25,500. So we're going to make a 16-bit divider instead of an 8-bit divider. To make our divider, we're first going to start with building the conditional subtractor. So we'll start with a normal 8-bit CCA, and then we'll turn it into a subtractor by turning on the carry in like this and inverting all of our B inputs. I'm just going to put a lamp here and a lever so we can start inputting B if we want to. Take this, stack it 7 up, and now since we need this entire thing to be 16 bits, we need to copy this whole thing and paste it above itself. So take the first position, take the second position from here, and I'm going to pick the reference point being right next to the first layer here. Now the first layer of the next stack up has to be 1, 2, 3, 4, and then 5. Has to be on the 5th one, so 4 blocks in between them. And so we can go right here, / paste -a. Now we have our second set of 8 bits, but in order to combine them and make them the same adder, we need to put the carry out of this guy into the carry in of this guy. And in order to do that, I'm going to make this a upwards torch. I'm going to put the carry out right here. Make it power a block, which depowers a torch, into a small little redstone line, and then put a slab here, and you can actually move this line over to here, and now we have the carry out powering the carry in. So this is one giant subtractor now. If you want to, you can put your A input here and try out some subtraction. So let's do that right now. If we do 5 minus 3, we get a 2. And right now, as long as our answer goes through and it's positive, we should always be getting a carryout right here, because this carryout is telling us that we could subtract and we're getting a positive answer. Now, of course, this subtractor is not set up to work properly with negative numbers, but the thing is, we don't want it to work properly with negative numbers. Because remember, when we get a negative number, we don't want it to subtract. We want it to just keep going, keep shifting, until it can subtract. So in order to control for that, we're going to use cancellation, just like we've done a lot of times before. I'm going to put a comparator here, and I'm also going to put a comparator under here. And one of these is always going to be canceled. And we're going to put a dust here, block, repeater, and then we can connect these two lines. And make this setup for all the other 15 outputs as well. Now it should look something like this, and now we're going to build the part that's responsible for the shifting. So each input needs to be shifted up on its way back. And so we're going to do a slab thing again like this, block slab, all the way up like this. And then we want to put a repeater here. And then you can copy this all the way up. 7 up, 7 up. And for this one, it's going to be a little bit different because it has to go into this block. So now we can just use normal blocks the entire way. We can just go like this. And then for the other ones up here, we do the same thing as before, where we used block slab, and stack it 7 up. This one up here doesn't matter because it is running out of room. It can't get shifted into anything. And then of course you need these repeaters as well. Now you need the cancellation towers for both of these sides. So I'm going to start with a repeater here and stack 7 up, and then a slab tower. Actually, I'll make the slab tower going this way so we have more room. And then you can copy this entire part, pick a reference point. I'll pick right here and put it onto the lower half. Now you need repeaters into all of these. Copy these repeaters. And then take this slab tower and copy the entire thing. Oops, let me do it from... And there you go. When you're done, you should have 4 different slab towers, all for canceling these giant towers here. Since the carryout is going to be the thing that determines which side gets canceled, we're going to take it out from here, put a redstone, another block, 1, 2, 3, 1, 2, 3, redstone dust, and then we're going to start a spiral that goes down all the way almost to the bottom of these guys, but it's going to stop right here. And you're going to put redstone dust on all of these. Now to continue this line, you want to put a slab here with a repeater. into a block, which extends it down to here. Make a little U shape. And then you want a repeater coming off of this block. And then extend this by 1 and put a torch on this block. So now we have the carryout controlling for canceling the top half of both of our lines. Now let's continue the spiral for the bottom half. And put redstone dust. So one more block here, make it go down like this. I'm gonna put a repeater here, another dust, and a torch. And then I'm gonna modify the bottoms of these a little bit. I'm gonna make it into more of a spiral. So take it like this. And then this can be a block. And same exact thing over here. We're just going to modify it a little bit. And that should be good. Now let's double check that it's working. When the carryout is on, it's canceling this right side. So all of these 16 repeaters are on, and they are. And then when the carryout is off, all of these repeaters should be on. Cool. Now we need a way to save all these answers every time. So you can do that on the top half with just a normal set of repeaters and a slab tower. Whoops. But then for the bottom half, I'm going to do something a little weird. I'm going to put 2 repeaters, and you'll see why. It's basically because I want the entire unlock to be synchronized. So then I'm going to start from here and build up a slab tower. We don't need this. Build up a slab tower. Stack 5 up. And then you can put a repeater into here. Bring this out. And yeah, bring it out like this. Then you're gonna need this to come out over here. And now you just want your locking device thingy. So to build that, you go like this. You go like this. 1 tick, 2 ticks, torch here, and another torch here. So this will unlock them really quickly to save our answer. And you'll notice that now they all take 2 ticks to be unlocked. Because starting from here, all of these bottom ones take 2 ticks, and all the top ones take 2 ticks, because it takes this extra and the 1. So when we press this button, all of our answers should be unlocked really quick. So this should be a working conditional subtractor, and now we can test it. So I'm going to pull out this first bit so that we can actually input stuff into it. And so if we're sending in a 1 and we're doing 1 minus 5, well, the machine can't do 1 minus 5, so just give me a 1 back. And let's save this. Now you can see, since this repeater is lit up, the machine is doing 2 minus 5, which again it can't do, so just give me the 2 back. Now the next time it gets sent in, it's a 4, and it's doing 4 minus 5, which it can't do again, so just give me the 4. And then finally it's gonna do 8 minus 5, which it finally can do, and it'll give me a 3. And so we can keep going with this. Now the 3 comes along, and it's going to be a 6 minus a 5, which again it can do, so we should get a 1 out here, and then we're back to where we started. 1 comes around into the 2, into the 4, until it gets big enough to subtract 5 from. So now all we need is a way to gradually shift in our A number starting from the bottom. And to do that, I'm going to use a giant extra tower thing, just like I used for the multiplier. Start this tower, go out by 1 block from this lever, and then go 1, 2, 3, 4, 5, 6. And then the next 2 blocks are going to have repeaters on them. This one's on 4 ticks, and this one's on 3 ticks. Then you want a slab here, block here, slab here, and then continue this down. 4 ticks, 3 ticks, block here, and then a block here. And then put redstone like this, and you're going to stack this entire side 15 down. And then you're also going to stack this entire side 15 down. Now you want this to be redstone, this to be a block, and then this to be a repeater. And then you're going to go 1 down and do the opposite. So these are going to be alternating. You're going to do a repeater here, and these are also going to be alternating. So you're going to do a dust here. And then copy this block down, grab a sticky piston. Sticky piston is going to go right here with a lamp and a lever. And same thing right here. Sticky piston, lamp, lever. And now you can copy this whole part and stack 7 down. Now you want a repeater on this block and stack the whole thing 15 down. Then you need to start a spiral from here. So I'm going to bring this down. And then I'm going to stack it uh, 4 down. And then over here on this block, you can get rid of those for now. Place another block here and then a dust here. Then you want to bring this out and put a repeater under it, into a block, into a redstone, and then this redstone is going to go down like this, and then it's going to start another spiral. All the way down here. Whoops. Until it meets up with this redstone here. And just make sure that every repeater and every dust is connected to the tower. And I just noticed this guy isn't connected, so you can connect it just like this. Now we have to delay some of the repeaters so that this whole thing is synchronized. So starting from this repeater that we were just messing with the L around it, we're going to make this 2 ticks, and then we're going to make every other repeater below it also 2 ticks. Now for the other spiral tower, you can start by putting blocks on all of these and stack 15 down. Then this spiral tower is going to go down like this. And you can stack this entire tower by selecting here and here. And I'm going to stack it 6 down. Now for any of these repeaters that don't go through a block and power a redstone like this one, you'll have to put another redstone on top so that it can power it from here. And so you have to alternate with this in order for all the repeaters to reach the spiral. and I'm also going to put an extra one on here. Now you can connect these by putting 2 blocks like this and a slab. And then starting from the top of the tower, 1, 2, 3, 4, 5, 6, 7, 8th repeater right here. You're going to go to this block and just put a repeater setup so that it can continue the spiral like that. Now we need this 8th repeater and below to all be 2 ticks to adjust for the timings again. Now take a repeater out from the first tower, go down by 4, and just line it up with this guy. But we need a delay here. We need a delay of 10 ticks. So I'm going to do 4, 4, and 2. Now we need the end of this spiral tower to do something. We need it to be unlocking these repeaters every single time. That's why there's repeaters connecting to this spiral at every point, but these ones depend on what we're coding for. So this goes down here, like this, down by 1, down again, and down again, bring it across, and it just needs to be input into this guy right here. So bring this all the way down, connect these two with redstone, and then you need a delay of 2 ticks. Now that our tower is all finished, we also need a way to save the answer, because right now our answer is just flashing through on this carryout. So to do that, I'm going to go 1, 2, 3 like this, and then I'm going to start going down with the spiral. So I'm going to make 4 blocks of it here, and then I'm just going to stack it. So take it like this, and 1 here, 1 here, stack 6 down. To continue the signal strength here, just build a slab with a repeater, and then a block, and then redstone like this. Then when it runs out again down here, you can do the exact same thing. Put another slab here, and a repeater into a block, and this time we're going to bring it down, go out 1, 2, 3, so this is 4 blocks, and then another 2 like this, a lamp, and then the whole thing with a wire. So now we have to start a tower that shifts up, because this carryout is always going to be brought to the bottom here, and then it's going to be shifted up to give us our answer in a nice vertical form like the rest of them do. So we're going to put a slab here, block, slab, another block, and then a repeater, and then this is going to repeat, so you're going to end up having another slab here. So we can stack this whole thing up 14 more times, because we already have 2 lamps and we want a total of 16. So take this whole thing, stack 15 up, take this part, stack 15 up, and then take this whole part and stack 15 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is our final output right here. So we don't need to do anything past that point. Now for the actual locking mechanism, we're going to start with 2 repeaters on the first 9. So stack 8 up, and then a repeater and a block on the other 6. Stack 5 up. So it should look like this. Now from the bottom, I'm going to go up like this, and then our first repeater is right here for that special circuit again, the one that depowers it for 1 tick. So let's build that real quick. We have 1 tick, 2 ticks, we need a torch here, torch here, and then you can continue this up with a slab tower. So take this part, stack 6 up, And then right here, we need another repeater into a block like this. And then we're going to continue to have a slab tower all the way up until it powers all of the repeaters. So now if you go down here and press a button, the whole idea is that all of these repeaters should be unlocked synchronously. Now what we need to do is make the clear button. So the clear button is going to open up all the registers, and then it's also going to cut off the machine and kills all the lines, just like we did in the multiplier. The first step to this is making sure that we can unlock all these repeaters. So put a piston here with a redstone torch, and then do the exact same thing over here. Go to this block, sticky piston, and redstone torch. Now in order to cancel all the lines, I'm actually gonna replace this slab with a redstone into blocks for all of these, including this bottom one, which means that we have to bring this guy up. And then same exact thing down here, just replace all of these with blocks. The reason I'm doing that is because now we can just easily put pistons right here, expand one up, stack 7 up, and then do the exact same thing up here. Now we have a way to retract all the lines and essentially kill them so that they run into nothing. Go to this third piston and put a repeater here. Bring this down into like a spiral thingy and just make sure it powers those pistons, and we can test this while we're doing it by putting a torch here. So the first 3 pistons are powered so far, and then as usual we do a slab tower, and we're going to stack this really high. We're going to stack it like 15 up, and whenever it runs out of signal strength we can just use a normal repeater to extend it like this. We don't have to worry about synchronization this time. So now it's just a matter of connecting those 3 functions to make the clear button. So the clear button is going to open up all these registers to clear out the answer. It's going to open up these registers to clear out our A input, and it's also going to just pull back all these pistons to open up the machine. I'll just connect these lines by first putting a torch here, going out like this, into a repeater, into a block, and then around like this, bring it all the way to here. You can start bringing this down, and they should connect like this. Then just go the other way and put a repeater here, bring it down like this. Whoops. And we should be able to sneak under this machine by going like this. And then just bringing it all the way up to here to connect with this line. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So just put another repeater there, and that should be good. Now 16 bits is a lot for it to flow out, and we're not going to have enough time with a normal button, so I'm going to have to make a pulse extender for this guy. So you're going to go 1, 2, 3, 4, and put a bunch of repeaters all on 4 ticks here. This is just to make a massive pulse extender thing. One block like this. button, redstone, and now this should be our clear button. So when we press this button, the pulse gets extended. It's pulling back all of these pistons. It's clearing out this line by retracting the piston, and it's also clearing out this line by retracting the piston. One thing I do want to mention is if you clear it with the B digit being 0, so this entire column being a 0, the output is all 1s. That's because it's continuing to subtract 0 and it's saying, yep, I can always do that. So in order to clear it properly, you need to just at least put something down, like a 1 over here. That way when you hit this button, the answer register gets fully cleared out. The very last step is to just have a nice space for our calculate button. We could just put a calculate button like right here, and that would be fine, it would work. But I want to put it right next to the clear button like it was for the multiplier. So to do that, just put a button here, repeater, bring this all the way out, make it into a another big slab tower, and I'm going to test the signal strength while we go. And that doesn't interfere. Good. Well, okay. And one last thing is we need to go down here to the second spiral tower and come down with a block, go under here, all the way across, line up with this guy, put a repeater on 4 ticks, and then have this guy connect to depowering this torch. And you will need another block of space. And just a small correction, make sure this bottom repeater is also getting locked by this same line here. At this point we should have a working 16-bit divider with an answer right here and a remainder here. So let's do a giant test with just some random numbers. I'm gonna put in, and I'll put it on screen too. And we'll do a smaller number over here. And now I'll hit calculate. Now it does take a lot longer than any of the previous ones because these are 14 tick loops, 14 plus 3, I'm sorry, 4 plus 3 plus 4 plus 3 is 14. And each of these 14 tick loops is 1.4 seconds, and there's 16 total of them. So, yeah, it takes like 24 or 25 seconds. And this is correct. We just did 60,779 divided by 725. And we got an answer of 83, 1010011. Remainder 604, 100101110. So like I said before, we're going to multiply the top number by 100, but we're not going to use a multiplier for it. We're going to do something really similar to part 2, I think, of this series, where when I multiplied by 10, I did a triple upshift to multiply it by 8, and then a single upshift to multiply it by 2, and then I put those together to give the multiplying by 10. We're going to do pretty much the exact same thing with 100, but instead of 8 and 2, we're going to use 64, 32, and 4 because these three numbers put together equal 100. So to show you what I mean, if the user types in 5, which is 101, what we want to do is we want to multiply it by 100. And so to do that, we're going to first shift it up twice to multiply it by 4, which is this number. Then we're going to shift it up 5 times to multiply it by 32, which is this number. And then we're going to shift it up 6 times to get this number, to multiply it by the 64. And if you add these three numbers together, you should get 500 because it's 5 times 100. So I'm going to start off with a 16-bit CCA and copy the entire thing. I'm going to copy it from right here. And I'm going to go over here, put a space of 3, and then paste -A. Now what you want to do is put all of the outputs from this guy and route them into the inputs on this guy. Should look something like this. So now what I've done is I've taken 3 slices of 8, all resembling the shifts that we want. This first one is a shift up by 4, so it's a double shift. You can see the first one is already going into the 4, which is 2 higher than it normally would. All of these are going 2 higher than it normally would. Second one's going into the 8, third one into the 16. And so yeah, and then this middle one is a, you shift everything up by 5, so everything's being multiplied by 32. The first one is already going into the 32, second one into the 64, etc. And then the last one is really similar, just 1 higher, because this one is a times 6 up shift, which is multiplied by 64. So yeah, first one's going into the 64 already, second one into the 128. So now we just need to take our 8 inputs and split it 3 times so that it goes into all 3 of these. And I have a thing to do that right here. And so you just connect them all with this block slab pattern so that they can stack. So I'm going to copy this whole thing. And I'll go right here, / copy. Paste. And I'm going to undo because I actually want to paste it without error, just so that we can keep the rest of those repeaters. And if we line everything up right, each level should be going into the level corresponding to each of these 3. So what I mean by that is this is bit 1, right? So now bit 1 is going into the 4, the 32, and the 64. So we're essentially doing 1 times 100. And our final output should be 100. And I believe it is. If we get a lamp, 64 plus 32 plus 4. Yep, that's 100. So now I'm just going to stack this whole thing 7 up for the rest of the 8 inputs. And now we can multiply whatever 8-bit number we want by 100 just by using these adders. So let's put a little bit more lamps here. Let's do the 5 times 100 like we did in the example. So 5 times 100. Let's grab a lever. And this is 500. 1111100100. So now we have to take our multiply by 100-inator and plug it into the input A of our divider. So I lined up all 16 outputs of the multiply by 100 thing. I just took the top 8 and shoved them down a little bit. And now this directly lines up with the 16 over here. So now I'm going to be extremely careful and copy this entire thing, rotate it by 90, and put it onto here. Copy and paste -A. So there we go. This giant thing, which is literally bigger than our entire divider, is just responsible for multiplying our A number by 100 before it goes into the machine. That's kind of crazy. Now the other thing you can do is bring the B around so that it lines up right next to A. So I'm going to take this, move it around to here. Let me first expand this and stack this down. So A comes out to here, and then B, I'm going to line up all of B right here to line up with these first 8 lamps. The top half of B is not going to be used because we're not doing anything to the second number. It's just still a boring 8-bit number that they put in on the display. But if you want to destroy these lamps, make sure that you just replace them with a block instead, because you don't want to get rid of these torches. These torches are important. The top half of B still needs to be inverted in order for this whole thing to be a subtractor. Alright, so I took B and brought it all the way out here so that it lines up with A, and now we have our 2 8-bit inputs. And just to remind myself that you don't want to mess with these, honestly you can just grab like a redstone block, and instead of lamps with torches here, just put a bunch of redstone blocks along these. So this giant weird looking thing should be our working divider, and let's try it out. So we're going to do 2 divided by 3, run all the way over here and hit the calculate button, and while it's going I'll get my sign out again. So 2 divided by 3, what this thing will do is it's going to do 200 divided by 3, and it's going to give us a 66, remainder 2, and yeah, on the display it will show up as 0.66, and we won't care about the remainder at that point. So let's see if that happens. Looks like it's still going, and done. So our answer is 66. This is a 64 and a 2, 66, remainder 2. So back at the calculator, we're going to be doing the same thing that we always did. We're going to bring A line out with a slab like this, and we're going to bring the B line through A. This time you don't actually have to go through because, well, this is the last operation, so you can just bring this guy down with a slab as well, and put some repeaters. Boom. 7 down. 7 down. And 7 down. Now we're ready to paste in the divider. So copy it, rotate it, do whatever you need to do. Get to your repeaters. Paste -A. Boom. Yeah, this guy's a lot bigger than the other ones. Alright, let's test addition, subtraction, multiplication, and division all at the same time. On the top, I'm going to type in 109. On the bottom, I'll just do 236. Alright, now I'll fly around to each one. I'll put on screen what we got and whether it was correct or not. So over here, this is our answer for addition, this line, and then this is our answer for subtraction. I know I'm at least somewhat right because we got a 0 on the top, which means it's a negative answer. And for our for our multiplication and division, we have to hit the calculate button on both of them. So let's hit calculate for multiplication and calculate for division. And multiplication is already done. And division is still chugging. Done. Thanks for watching.